about my musical integrity. How dare you? Hi guys, and welcome back to Afro 3D Printer. Today we're going to be interviewing Brook from printrbot. 2017-2018 New Year interview. Why not? Let's get on with it. First of all, I think I'll introduce myself. Afro 3D Printer with Brook from printrbot. He's kindly offered to be here during the new year to give us some insights into what's happening and what's not happening with printrbot. What actually got you into 3D printing? What was the spark that fired you off?
Well, I'll keep this short because a lot of people have heard this story, but I was doing a multimedia business, so I was building websites, and Squarespace and some, WordPress and some other easy to use website tools came along, and I kind of saw the end was nigh,
Yeah.
So, and I was pretty bored with it, to be honest. I'm a creative guy, and been an artist for years, and I love digital media and video and all that. But after a while, you do it for years for client work. You don't get to do your own creativity. You kind of just have to do what they want you to do, which sometimes was just, here's Apple's website, so I just want that.
Like the factory work, factory.
Yeah, I didn't. Anyway, so I got bored and wanted to do something more creative, wanted to do something that used my hands and I could get out in the garage. And I had all kinds of maker hobbies before, but this was really before the term maker was coined by Dale at Make Magazine. And so I just thought I was a tinkerer or an early adopter of technology. And I was always in the garage working on cars or electric vehicles, just whatever.
I think that's called geekism, isn't it?
Yeah, I think a total geek and proud to wear that badge. But my wife, actually, we were at a bookstore and I was in the computer section looking at programming and stuff. And she walked over this magazine, Make Magazine, with Bree Pettis on the cover, with his, digital manufacturing at home. And it kind of blew my mind. I never really had money to get nice tools. And I was always just coveting the other guy's tools. And I thought, oh my gosh, I could build jigs and actual, things that I want to build with plastic. This is awesome. So been interested in CNC for a long time, but again, never could afford it. So this was like perfect match. Got the magazine, subscribed to the magazine, and that's really the seed that changed my life. I was like, oh my gosh. And being an entrepreneur just my whole life, way back when I was out of college, I started a restaurant coffee shop, and it was actually an internet cafe, like right at the beginning of the internet, before Starbucks rolled into town.
You invented Starbucks, yeah?
Yeah. And so we had music in the place, and I just loved being my own boss, and my wife worked with me, and I had a roommate from college. And so I knew how to run a business, but looking at these 3D printers, I was like, oh my gosh, MakerBot is really the first one. So there's room to get in now, and it's early. So I thought originally I was totally enamored with this whole open source idea and loved the idea of open source hardware as opposed. I've been into open source software for a long time.
Yeah.
And thought, wow, this is pretty mind blowing. These guys are ballsy. They just go out and give away their plans and let somebody produce it. So I considered like doing a knockoff MakerBot for a while, but after owning that, I'll grab it. After owning this thing for a while.
Yes, that baby. Who can forget that?
And this thing was no good.
Oh, yeah.
It was,
it was a lot of work. It was a lot of work. That was a lot of work for that thing.
Yeah. Taught my son to solder on this, and my kids at the kitchen table, I forced them to help me build this thing. So I knew it was possible for a family or dad to, my kids were young, and I thought, man, this is going to be great for schools. And just really began to dream about what was possible in the future. And so I thought, well, I'm going to build kits, but it's got to be easier than that thing.
Yeah.
So what I focused on mainly was simplicity of the design, and I built a Prusa. It was unbelievably hard, mainly because it was the open source community has been bad. The bad is it's like herding cats, and everybody has their own idea of what would be best, and nobody agrees. And so, at least in the early days, we still didn't know what firmware we were going to use, what electronics, and I needed an answer. If I was going to build and move quickly, I needed an answer. What is the best electronics? What's the best hardware? So I'd get all these opinions online. I remember trolling the IRC chats of the early firmware guys, and I said, "Hey, I'm going to start a business," and people just cursed me out and were like,
yeah.
"You don't know what you're talking about. You're not a real 3D printer guy. You don't even have a working printer." Anyway, it was brutal at the beginning, but then I just decided.
Yeah, they can be sometimes. They can be sometimes.
Yeah. And by the way, there's also wonderful people like Rich Rapp, Knophead. I mean, there's some real leaders that were very, very friendly and open.
Well, give them a shout out.
Yeah, absolutely. Those guys, especially Rich, I've been able to meet him, and we're friends as far as friends that meet once and talk online.
Yeah.
But great guy, very knowledgeable. I love these engineer minds that are out there that are really trying to get at solutions for these very real but solvable problems.
Yeah.
So anyway, I just decided, well, you can't lead a company without a leader. So I guess I'm that leader, even though I don't know what the crap I'm doing. And so I started a meetup group to start to test some of my designs and ideas.
Yeah.
And here in Northern California, we're close to the Bay, and it's a pretty rich culture here for electronic engineers and startups and very, very smart people.
So you started to network and gain contacts?
Yeah, so I just started a meetup group out of the blue, and I had my MakerBot working, but I had not yet successfully finished my RepRap.
Yeah.
And the funny thing was I put it on meetup.com, and the first week was like 2 people plus my daughter. It's like, yes, I was excited to just have 2, and it grew rapidly from there, and we had as many as 60 people.
So over what period of time did it happen?
This was the beginning of, I posted it and got my right when I got my MakerBot kit, I said, we're doing this. And it was January of 2011. And then eventually, it was only 3 or 4 months, I had a working printrbot, and a lot of people giving me advice on electronics. Found Carl Ubis. He was in my meetup group. I showed him the hot end I built with a drill press and some Harbor Freight parts off the shelf. And he said, "This is crap." And I was like, "Well, can you do better?" He was like, "Of course I can do better." And he was 30 years at HP running the printer failure analysis lab, which was like really a godsend. He
printer failure analysis lab. To me, that says detailed.
Oh yeah,
that means detailed. If he's doing that means he's ticking the boxes. What failed and
exactly. And he saved HP so much money over the course of his career. Just these wild problems, and when you're in 3D printing, you realize there's a lot of stuff that is like hard to understand and like tricky to troubleshoot and stuff. Yeah. So the hot end is really, for years we had. Well, not that many years, but those early hot ends were just really bad. Not a lot of scientific data. And, you can't just drill a bolt and expect it to work, with abrasive plastic. And so we were just kind of getting to know what we needed in a hot end. But Carl designed this beautiful hot end off-the-shelf parts mostly, and then really learned a lot. This guy's still with me.
You're obviously an innovator and an entrepreneur, and you started something, I think, quite fearlessly by doing a Kickstarter and getting your hands dirty, and you've built up a product which is, I think, probably international now, because in the UK, obviously, I've heard about it and I know about printrbot, and it's got I was going to say quite a good reputation, but actually it's not quite a good. It's got an excellent reputation, printrbot, in the UK. I don't know about anywhere else, but it's got a very excellent reputation. Yeah. For those people that show off what they print, the print quality is excellent. The machine, as you say, the solid metal cutting that you water jetting that you do it says quality, yeah? But in your mind, as an open source advocate, what do you see the future of printrbot doing educationally and also machining? How do you intertwine those two together? I know it's a difficult question, but how do you intertwine those two together and spread your, I'll call it your project, further?
Well, there's definitely some trends happening, and you kind of have to align your dreams when you're leading a company. There's like what I want, and then there's what the public wants. So you kind of have to come to grips with who your audience is first. Yeah. And all 3D manufacturers that started small, like me, and actually MakerBot was one of them. We all had the dream that there was going to be a printer in every house.
Yeah.
And we would have guessed, oh, it's going to take a few years, but it's coming. Well, here we are 6 years later, and it's not there yet. So I have dreams about what an open source hardware company could be. This whole decentralized manufacturing. The idea of printers was pretty novel, and that idea of, well, then this is possible. We could print parts that people use in homes, and then they could sell those. Well, part of that has happened. So the RepRap movement does continue, although it's greatly diminished as far as enthusiasm from the masses. The enthusiasts have grown, but those 6-year-old guys that were blazing the trail have just become more and more and more, I don't want to say militant, but they still believe in the idea of distributed manufacturing and the whole world getting access to the technology, like Adrian Boyer, who really started the RepRap movement, really believed. But you kind of have to come to grips with the fact that it hasn't happened yet, and this maker culture is indeed a finite size. Even if it grows and we find all the makers who self-identify as makers and aren't scared of printing and assembling and uploading firmware and doing the wiring and stuff, that's still a finite number. So that dream of it's going to be in every home really has not emerged, and I don't really know how close we are to that. But one thing that I think everyone agrees is education is a nice match for that dream. So I've always been into education. I feel like I'm not trying to throw anybody under the bus, but I feel like some CEOs use education as a marketing ploy.
It's a commercial strategy for some companies to do it.
No, I don't mind with people. First of all, I am a capitalist, right? I mean, I have to be if I want to stay in business and keep doing what I love. So we have to make money. Yeah. But a true believer in open source hardware does not have to approach education from this idea of scarcity, that if schools really start adopting an open source design, then they're not going to sell printers. It's just not true. And the data has shown that if you can just get brand loyalty and just be a friendly customer support resource and share information, that lowers the fear for a lot of teachers. There's a lot of barriers in America specifically to getting into education. Over in the UK, it's a little different because there's like government mandates on what will be taught and things like that. Yeah. But there's a bunch of wild west here in the US. Okay. It's not just state by state because they don't really federally mandate it. The states handle it, but even in the counties, it will change dramatically.
Okay, yeah.
The leadership of schools and the decision makers, they are somewhat budget conscious, but I don't really see budget as the main barrier to entry, because when they do get money to get a 3D printer, they do look for something. They don't want to make a mistake with it.
Yeah.
And so, just downloading plans and saying, yeah, I'm going to use $30,000.
Everyone doesn't want to get his mistake. They don't make mistakes with computers anymore, do they?
Right.
Yeah. Exactly. And that's another point I want to raise with you. You mentioned about people not willing to have a 3D printer in their home, or there's no capacity because it's a finite number base for 3D printers, not 3D printers, but 3D printers, to say, so to speak. Yeah.
Right.
My thinking on that would be that, the same way we have computers in every home, and the same way we have paper printers or inkjet printers or laser printers or laser color printers in every home, is the same way the 3D printer technology will eventually migrate to. Although currently we still have this kind of like thing where it's a learning curve. What can we do? A lot of people say to me, especially those who are, let's say, more elderly, a bit more mature, what can you do with a 3D printer?
Exactly.
What purpose does it solve? But you show a child it who's learned SketchUp in school or some CAD software, I say, oh, I want to make this. Oh, I want to make that. Oh, I want to do this. You show a jewelry maker, they say, oh, I want to do this kind of jewelry making or this kind of thing. You show a woodworker, they know automatically, oh, I want to do this with it. Very specific things that they want to do with it. And there's that kind of like evolution or transposing of knowledge to another general set of people out of the lab, out of the fish tank, so to speak.
I think a lot of things are starting to converge. A lot of disparate, it's a unique industry. I don't know that you can say that this is going to progress just like 2D printers. I think computers might be, in general, might be, because you actually have tinkerers way back. The start of computers was tinkerers in their garages. But when it comes to 2D printing, the only thing that you saw enthusiasts do were print their own calendars and newsletters or signs and cards, and it wasn't truly as good until you got to pictures with color printers. It wasn't really that novel, and you certainly didn't build your own printer. But going back, there are a lot of analogies that hold true, parallel with the early computers. So all of these things have been progressing, and I do think the key question is, well, what do I print with it? And so I can tell you that if the whole world, if we do finally get cross that chasm, I don't know if you've read that book, Crossing the Chasm, but there's an updated version that you should read if you haven't read it. But basically all it describes is this bell curve, and we're in the very early stages. About 3 to 4% of the population are enthusiasts. And then there's a gap that always happens with technology, and this is a book focused on technology. There's always a gap, and to bridge that gap, that chasm, to true widespread adoption from what they term as early adopters. Like I say I'm an early adopter, but no, I'm even before that. I'm crazy. I'll buy stuff that I'll never learn to use and spend hundreds of dollars doing it. The early adopters are the ones that went out and bought a microwave oven finally, back in the 70s or 80s. Yeah. It's easy enough now for mere mortals they've got the money and they're a little more expensive. So that's kind of the bridge that we need to cross if this is going to get into every home. Now, there are some things that are converging, but there's some difficulties that are coming. And here's what's converging. The materials have gotten a lot better. Yeah. We all used to print in the Kickstarter, it was all ABS, and that was a pain in the butt. The machines were primitive and not that reliable. Now they're quite reliable. Yeah. And really they've kind of plateaued to where we haven't really got to multi-material, multicolored printing as being easy. Yeah. Although I do think that, what's the company? Mosaic. We're talking with them about carrying their new one. That really makes it easy. Yeah. But still, you have to get in there.
It's a nice process. I looked at the Mosaic, and I think it's a very nice process in Mosaic. I mean, I've looked at several others, including the Diamond Head and others, And, I looked.
Something printed by a Mosaic.
Not bad. When it's calibrated, very nice, very clean. Yeah, I've noticed a few prints where uncalibrated and people didn't know what they were doing. Yeah, and the quality is exceptional.
Just welds that filament together, and so you don't have to worry about managing multiple heads and all of the tolerances.
A lot of maths. And what I am impressed as well is the reduction of the. That's nice. Yeah.
Very anyway. Nice. Yeah. That is progressing, and I think it's what needs to happen. But the software has to get better, and so the software has been horrible.
A lot of maths going on in there.
Yeah, it's lots. Yeah. And now we've got manufacturers coming in and saying, well, to get an edge, we're going to make our software proprietary. So you got MakerBot that only works with MakerBot. And all of these slicers, the most complicated thing about this whole deal is all of the math that goes into slicing these models. So while Slicer or Slice 3D or 3R or whatever you want to call it, that and Cura are the two leaders. And so Cura still is kind of like starting to edge more towards proprietary, at least be first and foremost about Ultimakers. So maybe that one will fall away in popularity amongst the open source people, but Slicer's probably going to be good enough. But anyway, so the slicers were bad and now they're good. The materials were pretty bad and now they're stellar. The reliability is good, so we're getting there. But the thing that has been left behind is the software and ease of use, the overall user experience. So what I look for this year in more and more companies, or at least the companies that are starting to get a handle on it will get even further ahead, and we hope to be one of those, is you have to have ease of use. These kids, here's the problems with today's culture. Back in the day when my dad got his first computer, he was totally down to like insert a card and turn a screw and take something apart and run a ribbon cable across the room and, fits around with a tape player until you get a good recording on your hard drive. They were tinkerers back then. They were used to fixing their own cars and changing their own oil.
But the kids now have a very disposable culture.
Totally. If it doesn't work on this, then they don't know what they're doing. They don't even programmers have never built. My first programmer was 17 years old, a brilliant kid, and we were talking about building a local server to take. We stripped. I told Bree this. I stripped all of Thingiverse. I downloaded every model that was open source. Hit that website and download it.
Get that down.
And he told me, we have meetings about you and others that are totally scraping our website. And I was like, well, this is expensive if we try to do it in the cloud. Let's do it locally with like a little server Mac. And I was like, hey, you've built computers, right? And the computer programmer kid was like, no, I've never built a computer. What are you talking about? And I was like, how can you be a programmer and not build a computer? He was like, I have an iPhone. That's my thing. Or like a MacBook. Anyway, and you can't open a MacBook really.
There is that. I know what you're saying. There is that knowledge gap, and within that knowledge gap, there's that whole thing where someone says, "Oh, I'm a coder," but when you say 6502, they go, "Huh? What are you talking about?" It's like they don't understand. They don't understand. You've got things going on underneath the computer about actually doing stuff. And the same way a lot of people think, with 3D printing, you've got the G code, but some of them have never looked at a G code table to know what's actually what's going on there. All they know is I make the model, I plug it in, and it's plug and go, and that's all. Exactly. That's all they see. Yeah. So some manufacturers they're trying to they're starting to realize that really the barrier is you hand somebody Prusha, he's a friend now, and he's a really interesting guy. But he puzzles me, as well does Lulzbot. These guys are so into the open source that they still believe that printing parts is a good idea. I totally disagree. As far as if you're going to have a commercial application and cross that chasm, people are not going to put up with printed parts as something they spend hundreds of dollars for in a printer. But he believes in that, and you give your neighbor, if you just walked a Prusa i3 Mark II or 3 or whatever they're on, over to your neighbor, it's going to have that little funky LCD dial on it that looks like 1980s, and they're not going to know what to do. Where do I swipe? And what do you mean I got to plug it into a computer? I don't do that with my printer. I mean, my paper printer. So it's got to look more like. I'm not trying to plug my products, but I just want to illustrate. Look, listen, Brook. This is your show, mate.
When I give a kid,
that is a thing of beauty. That is a thing of beauty.
Let's see if I can plug it in. I had a kid here with his dad. And his dad was designing some medical device and wanted me to print a prototype. And he brought his kid in, and I was like, well, I was going to train you. Why did you bring your kid? And he says, well, because my kid is going to be the one that runs it. And I sat him down, and as soon as he saw the touchscreen,
Oh yeah,
he just
straight into
reached
it.
out and started swiping.
Yeah.
And it's something that's familiar.
Yeah.
There's a
User interface
screen
is
that,
very important. Oh, look at that! It swipes as well. Wow.
yeah.
It
And then
swipe.
when you're ready
It
to,
swipe. Look, it swipes. I'm telling you, it swipes.
yeah,
Yeah.
exactly. So to print
It's,
something, you just hit print, and there it goes. It's starting to
oh,
work.
wow. Okay.
So that is the user experience that I think the masses need.
That is next level. It is next level. I think I agree with you. Like the user interface experience is very important, as is the user interface in itself. Because what you want is that kind of ubiquity between yourself and the device, and how it works, how it performs. And a lot of I don't know. Are we in third generation 3D prints or second generation? I don't know where we are at the moment.
It's hard.
It's hard to define. We look back and we'll define it later. But I think this generation of computers for 2018 is moving to user interface design and interaction level, where people feel like, actually, do you know what? I'm interfacing with this printer, and it's giving me a nice feedback, whether it's a buzz, whether it's be haptics, or probably not haptics, but that kind of feeling.
I get it. Now, I do think that there are companies that are like, oh, I have to dump that LCD 20 characters by 4 characters panel and go to a touchscreen, but I don't think that's enough. This is what kids recognize, the phone. And so our printer here, you can just upload your file through a tablet, a phone, any browser. This is the computer of today's kids. So it has to work with this. So you can set up your printer on Wi-Fi on our cloud, and you can send a model through here. Anybody with we can have 20 phones connected to the same printer, all loading up files. So we need a user interface that isn't just on the printer, but you need something that's familiar to the general public, so it has to be the cloud. Now, there's pushback amongst enthusiasts on this whole idea of cloud. And I've been living in the middle of this for about a year now. And first of all, when you say you don't need a USB cable, the comfort zone starts to get, for older guys.
You always have a USB cable as a backup. Always.
Yeah, and I took away their SD slot too.
So forcing us to the cloud. Is that a Microsoft strategy?
No. But funny enough, check this out. It's funny enough, Microsoft came to me and they said, we love your printer bots. The guys here in the 3D printing squad in Microsoft, we own printer bots, and we love them.
Cool.
And we love the open source thing and the open source hardware. But why don't you publicize it works with Windows, and what about getting Windows drivers into Windows? And I was like, you mean I could have drivers already available in Windows? And they were like, yeah. They said, okay, so get a Microsoft program. And I was like, wait a minute, I'm a Mac guy. I hate Windows. And they were like, yeah, we know. We've watched your videos, but you got to get a Microsoft program. I don't know any Microsoft program. So I said, how about you write it for me? And the guy that was in charge, he's pretty high up he's been there a long time and used to work for the CEO, the now CEO. And he was like, I don't write code anymore. I'm a manager. And I'm like, but you do. And he was like, well, and the guy that was with him, we went to dinner in San Francisco. He says, well, you kind of already wrote it. You got yours working. And he was like, huh. And he ended up writing it for free and putting it in there. So you can plug it into Windows 10 now. It just goes ding. But that isn't as familiar to that ding is good for me to hear because I don't want to have to look for the drivers. The kids don't listen for the ding and that warm feeling that we do. They just want it to work with their phone. So they actually were themselves sick of that USB legacy culture that makes their job hard. So they have been making, they went to this IoT, Windows 10 on a Raspberry Pi and all this, and a print server and all that. But I think it was not because it was a Microsoft strategy. It was just the whole world is tired of cords.
Okay.
And so you see Apple going that way, dropping their headphone cords, dropping their charging cords. And I think there's more to just putting a touch screen. You have to dump the cords. You have to make it work with the phone. And once we get printers that are working that way, they've met where the world is, today's youth. Then we'll see some adoption try to happen. But back to your original question, what is the killer app? What are you going to print? we have two diverging ideas. One is that, well, we're going to digitize the whole world, and everything that you ever wanted.
Print everything.
These are prototypers, by the way. They print one thing at the same cost as 100 things. So we're just going to print more things. Now, obviously, not everything will be printable because we don't print metal, at least not cheaply. So there's that idea that the whole world's going to be digitized, or kids are going to learn how to design stuff. Well, if they're going to learn how to design stuff, the software has to get better. Fusion 360 and others have come such a long way. Even like Tinkercad, you know, kids can get some work done with that, but it's not a serious modeling tool. So it's going to have to happen in education. We're going to have to raise up a smarter, and I don't mean that kids are dumb, but sometimes my kids act dumb, but they're going to have to be comfortable with some sort of software that allows them to easily make something that actually prints and works. Yeah. And that's beginning to happen, but you know, shop class went away, and the skills of making were out of vogue for a long time. After I got out of high school, I was a shop class kid, and you know, I learned to weld and use a lathe in machine shop, and that went away. You don't even check your oil on your own car anymore. So that culture is coming back. So I think that's converging too, and there are definitely much more prominent in high schools today. You'll see a design class, and it might even be just problem solving, but they'll build a bridge, you know, out of, you know, whatever, tongue depressors, or you know what. Those type of engaging ways of teaching are coming back.
In the UK, we have several types of things here. We've got STEM clubs and class. What's interesting for me is to see kids take a little seed and grow it. That for me, that does it every time when they got something and you just push them a little bit and they roll with it. You know, it's always interesting to see where they go with it.
That's the exciting thing. It's why I remain so excited about 3D printers. It's not the printers. It's seeing these kids and people. I mean, old guys. I consider myself pretty old. I'm 46. You know,
not that old, mate. Not that old. Trust me.
Well, I mean, there's guys my age. I've met 80-year-olds with 3D printers, and you know, there's people that are excited about creating again, and it's what they create that is the exciting thing. That spark, like you said, that seed that is planted, and then they go off and pursue a dream of their own. I'm thrilled. I was talking with my wife. We were just thinking about the year in review, you know, this week, and we were just looking back on not. We don't get excited about how many printers we've sold. It's somewhere around 50,000 printers. But, you know, that's a big number, but that's not the exciting part. And it's certainly not the money. Money does not make you happy. And we've been way up and way down, you know. So it's like, you can't count on it. What's exciting is there's been companies started because they got a printer bot. There's been kids go into engineering because they got a printer bot. There's people solving real world problems with printrbot. It's like helping the world. So in very small ways, if you take all those little water drops in their own areas and put it together, you've got a sea change that's starting to happen. And not just with printrbot, other 3D printers, and not just with 3D printers, but CNC, and not just with CNC, but just creative solutions that are being found by young people and old alike, that they have access to so much more resources and knowledge base because of the internet, that things are really starting to happen rapidly with not just companies, but solutions to real world problems.
I think we're going to see a lot this year. 2018, I think we're going to see a lot. I mean, 2016 for me was really interesting. It was kind of like a pivotal point. 2016 went on and it got more interesting. I think 2018 is where you're going to have some very decisive manufacturing techniques coming out, and a lot of innovation, because people now know what they're actually dealing with. It took a while, but the education is there and people know what they're dealing with. Just to change this topic now onto something slightly different.
Sure.
Understand you're doing an upgrade to 24 volts. And I watched your stream and I thought, oh, yes, 500C?
Yeah.
Nice. Very nice. I was impressed. When I saw your video, I was impressed. So if you can give me 1 minute, tell me about that nozzle, please. Really want to know more about that nozzle.
So let me tell you about the whole hot end. So Carl has been a one-man army with these hot ends. He himself has produced probably 70, 80,000 of these. And I mean, he has help, but he's spearheaded. He's a
hold the nozzle there for me, please. Just hold the nozzle up so I can just hold it while you talk, please. Just that's it. Yeah, just talk about the nozzle because people want to see that nozzle. I'm quite sure they want to see it.
Let me scoot this up. All right. So anyway, but Carl has been up against some very, very difficult problems that have to utilize different materials, and he's really efficiency hound. I mean, it has to be efficient. So that's why we've gone with the ceramic. It's potted, so this is a ceramic insulator around a hand-wrapped wire, a nichrome wire heater. And I don't even know the secrets. He's so secretive; it's hilarious. I've been trying to get him on video, but you wouldn't believe it.
He's a bit shy,
yeah. I mean, you would think, and this is Carl has a lot of interests. He's a beekeeper. Yeah. But anyway, so he's approaching this not just. I'm not trying to bang on E3D because those are great guys. I've spent time with them, and I love that there's competition out there and they're doing good things. But when you take an E3D and especially the earlier ones where they were like running and gunning and just going for it, and they were selling like crazy and they were going. The difference in the approach in the two companies, Carl and E3D or anybody else doing nozzles, is just very stark, different. Carl won't do anything unless it's backed up by science and data. Yeah. And so he moves slowly in that way. But when he finally delivers a production hot end like this, it has been vetted. There's been hundreds and hundreds of small micro changes. He assembles these things with a stereo microscope. He inspects them with a microscope by hand. I mean, all sorts of stuff. But so here's what it is. It's an aluminum. It's aluminum up here, and it is anodized because you get like 1% better efficiency with anodized aluminum than just machined aluminum. And he cares about the 1%.
He is a scientist, yeah.
Yeah.
He's a scientist.
And I was like, 1%? Who gives a crap? He was like,
overall, it's a big amount.
Exactly. On the end here is a Delrin.
Could you raise it up a little bit, please? Raise it up into
up on the end here is a Delrin cap.
Yeah. And
there's several advantages to this, but it's an additional insulator when you clamp it into, say, a plastic, extruder. You have to worry about the heat going.
Yeah.
You do have to run a fan across here. For a while, we were making hot ends without the need of fans, but when you're going up to 500 C, trust me, you want a fan. Yeah. And then this is just a high temp, like fiberglass and silicone sleeve.
Yeah.
That will start to smoke, is what he calls it, if you're going up above 300 C.
Okay, so
this is a replaceable item. It'll degrade. Just the rubber and silicone degrades.
Yeah, even silicone. Yeah, you have to. Yeah. Most silicon a lot of people don't realize most of the silicon socks you see actually low temperature silicon, and it will degrade over 250, 300 over a period of a couple of months. It will go.
This is actually fire rated, so it's like really hard to get hold of stuff, and but you can find it. But like I said, he doesn't share the secrets, but he's sourced this very good.
Yeah.
And then the potted insulator here, it's not only hand wound, but he did a lot of testing on the very distance between the windings matters, and you can wind them single or double, and so there's all these different techniques to properly wind it. He's found a highly optimized way to wind this with the right gauge wire, so he gets the exact right resistance, and with 24 volts, more power, he can have a very long life.
Yeah.
So the wire, he takes very great care to make sure the wire itself is rated properly. He's got additional sleeving here. This kind of maroon sleeving is additional to protect the wire, and it's highly rated itself wire insulator here for the power. So he's just really thought through that. And you can't get the one thing about the E3D style and there's a lot of different popular ones that you just take a block of aluminum, drill a hole in it, and pop a Chinese heater in it. Well, that is extremely unscientific, and some of the heater is exposed and therefore is open to the air, and they put silicone heaters around it and all this. But when you wrap wire around a tube, you can get that heat extremely close to where the filament is going to be.
Yeah.
So this is the first time he's done stainless steel on the interior. It used to be brass, but for high temp, you want steel for the strength. It's very, very thin in here. I don't know if you can really see that, but it's very, very thin wall.
It's clear. Yeah, I can see the.
That's the heat break.
Yeah.
It's where it changes from cool to hot. So that's something that others have done. But then this right now, this tip is just plated brass, but we're working on some high temp or highly, you put through carbon fiber, and it's going to degrade that orifice, and the inside is going to wear out. So for some of the harder filaments with, like the fiber chop in there, we're working on one that is actually got a core of ceramic.
Ceramic, is that going to be compatible like with the Olsen Ruby?
Yeah.
Or better than Olsen Ruby?
Well, that remains to be seen. And like I said, Carl he'd kill me if he knew that I was saying even this much. Yeah. But I'm like, Carl, they're going to buy it and have it. So they're going to know it's ceramic. But anyway.
Okay.
You know what I mean? So anyway, the tip is right now it's very good. And actually that nickel plating holds up really well with the long life. But the length of it on these, because of the longer melt zone here, this is the difference. You have to have a longer melt zone if you're going to go fast, or if you're going to go high.
Yeah, because you're pushing stuff out. Yeah.
Yeah. So I probably have the longest hot end on the market.
I don't know what to say.
Well,
lots of words.
I
hear you.
Well, I don't think if
you're not boasting, you actually have a long hot end there.
No, it's actually the truth. And some people make fun of me for that because they're like, "Oh yeah, it looks so old school." Well, listen, science is science, and you can't get around. I mean, like gravity; it's the law. You can't get around the fact that to heat up plastic, it has to be on the heat for a while to get to temp. So you can't do it in these microscopic.
As it get hot, and it has to have a bit of time, transition times, everything going on.
It has to, and the more volume you have, the longer it's going to have to sit on the heat.
Yeah.
So it has to be longer, and so this is just a requirement. So I let go of Carl. They're making these short hot ends. I want to shorten. He's like, no, it doesn't work. You can't do that. We're not going to do that unless you change the size of the filament.
I think it's a bit of the fashion as well. There's a bit of fashion with having short nozzles. It's like saying, if you're going to have a long nozzle, you're going to be pumping filament out of it. You're going to have a stronger structure and frame for your printer. And more accurate, machine,
that is true.
because you're going to need both. They have to complement each other. You can't put it on a clone i3 because there's no point.
Yeah, right. So with our printers, we solved pretty early the rigidity problem that my early printer bots built of plastic and wood. I mean, these things are like, I throw these guys around all the time in the car. I don't carry them with cases. I throw them in plain overheads. They just are extremely solid. They've fallen off the desk and it's kept printing and nothing damaged. So we have rigid printers, so I'm not concerned with the extra length of it. But anyway, so one other thing is he's really this is a new design for the bobbin here. He just simple things like he wanted you to be able to get a wrench in here instead of have this little. We did have this neat little tool. But the tool was, you could use an Allen wrench. It's just a sexy little tool. But you don't need that.
Yeah.
Just a wrench will hold it. And it's all properly sized, so you're not going to hurt the ceramic. And you can hold on to that while you loosen the tip and change that tip.
Makes a big difference. Little things like that make a big difference.
Another trend in hot ends is people are starting to put their sensor, because these little glass beads don't hold up forever.
Yeah.
They're putting them inside cartridges, and so this is a cartridge, and it has one here that accepts our current thermistor.
Yeah.
If you want to run low temp or want to back up, or you're in a pinch and you maybe pull the leads out on your new temperature sensor, there's this backup over here. But we're going to start putting those sensors. Right now, we do use a glass bead. It's kind of encased in silicone, but on the ends to hold it in place. But it's going to go to a cartridge too, so it's just more resilient. This is another high temp, even higher temp sleeve, and that is potted in with the cement that holds the little. It's not a glass bead anymore. This is kind of akin to, if you know, there's a difference between thermistors and thermocouples. Thermocouples traditionally require extra. It's based on microvoltage to measure the difference between two dissimilar metals, like welded together. And we've built something differently, and this is actually custom designed to have the proper envelope of resistance to measure temperature, but it's not a thermistor. It is welded together, platinum. So these are often called PT100 or PT1000. And E3D uses that, but you have to have this amplifier circuit that's expensive and like $10 just for that, or $14. And so you have to add this. Now you're adding electronics on this. You don't have to do that with this hot end. You just plug it in to your printer board or your G2, and you download a new firmware that has a new lookup table, because the resistance isn't identical. It's on a different band.
Okay. But quick question. Research time for that was how long? Research and development time for your nozzle, how long?
Over a year.
Over a year. So maybe 2 years, 2.5 years? From conception?
It's over 2 years, actually, now that I think about it, because we came out with a UBIS 13, and we thought we had cracked the high temp over 300 C. Okay. But the problem was, by the way, there's no Teflon sleeve in here, because Teflon breaks down at like 275.
Yeah.
So that made a lot of hot end makers' life easy for PLA, because it's very slick and it holds up in those temperatures. But when you go to putting plastic through metal, it's so abrasive. And it will degrade that wall. And if you do a retraction and send molten filament up beyond that little heat break, you've just made cement in the cool portion of your. It'll cool, grab the sides of the wall, and you're screwed. So we were having people not paying attention to the instructions on the old 13, and they would do like 3 millimeters of retraction, and it would just cement in there. Kill it, And I could drill it out, or I could get it out by heating it up, but nobody wants to do that. We dropped back into the 13S and fixed all those problems, and then this is what led finally with the need to print high temp. See, Carl and Brian, my old engineer Brian, he was on the TV show with me. Brian, he's a great guy, very talented. They've got a contract, Brian did, with a company that is, I can't talk about it because I don't even know what they do, but I know it's space related. And they have this proprietary filament that is like Ultim or Peak, and it has to print at 350, 400 C. Well, brilliant, because I need a high temp hot end. So that kind of pushed forward, that aerospace company pushed forward the development of this, because it shares some of the requirements. So anyway, we've got this this new temperature sensor. I'm very excited about it.
Well, you certainly got me excited about it, Brook, I must say. Such a nice nozzle you got there. That's amazing bit of technology there.
And what's cool is
it's not that big actually. It's quite small. It's in your hand, but it's a big little project you've got going on there.
What's cool is this is going to be $100, $99.
Not bad.
Yeah. So
not bad. Actually, good price point.
What I like is saying, just compare it to all the other $99 high temp hot ends that are high flow, and they go to 500 C. Because there aren't any, and don't require any extra electronics. And it's accurate. That sensor is accurate within 1 degree, even up to 500 C. And that's something that.
All I can say, Brook, is congratulations, mate.
Thanks. Anyway, so
you may become a nozzle maker company. Just to finish up, I want to ask you about. I think everyone's been, there's a lot of chatter at the moment about AdopterBot, and I think everyone knows about it. It's been going on for several months. I remember you when you launched it, and I thought
I'm doing
myself,
some today.
this is such a good idea. Yeah.
Yeah.
One
thing that I noticed. Oh, what's your question about it? What would you like me
No,
to?
no, go ahead. You're enthusiastic. I want to hear what you got to say.
Well,
One thing.
my big thing was, listen, I don't know if you know this, it's a little known fact that right after my Kickstarter, like a year later, I launched a second Kickstarter that totally failed. And that second Kickstarter was like, hey, now I can make cheap 3D printers. So I'll tell you what, I'll cut out all of my margin, no profit, and I'll sell them in bundles of 2. And you can keep one. It's even cheaper than my first printer. And you should donate one to a local school. And nobody wanted to do it.
Interesting.
Nobody wanted to do it. And it kind of pissed me off. I was like, wait a minute. We're a community of people giving back, aren't we? And people responded, no, not really. Well, now we got all of these makers with, I still am amazed. You know, I'm always glad when I look at my reports and I say, hey, new customers. That's great. But let me tell you, without my community buying, some of them buy every major printer that I do.
Yeah.
They just keep buying printers. And I'm like, wow, there's a very large portion
That's
of
a good
my
support.
business
Yeah.
that are just enthusiasts.
Yeah.
And I'm like, why do you need 2 printers? Why do you need 10? Why do you need all these printers? And so I started asking around, and it turns out these makers, I mean, look behind you, friend. You've got stuff that you may not use in the near future. And I say, well, these are people with, I'm not saying it's you, but, you know, it's definitely me. Look behind me. I have more printers than I need.
Yeah.
You know, I got printers.
You're going to use, you got to use those printers, mate.
And I looked one day on my shop grew and grew and grew with the needs of the peak of the market. And then when the market fell, I really just had a lot of storage space that I needed to get rid of. And so I started going through my shelves and thought about downsizing. You know, my CFO likes to call it right sizing. But while that's painful, the beautiful thing is you find all this stuff that you can give away.
Yeah.
And so I literally lined up over 40 printers that could be, you know, tweaked into working printers. They'd just been robbed or, you know, whatever, in the dust for a while. And I thought, I got to give this stuff away. Who deserves them? Not these enthusiasts, because they have them themselves. Let's give these to schools. But I needed help from the community. So the value of the community is not resources of, you know, extra filament on your shelves and extra printers necessarily, but it is the knowledge. And you've got to share that with your local youth or enthusiasts. So I decided I'm giving every one of these, instead of trying to sell these or eBay them or something, I'm giving every one of these away to schools, but I need the community's help to just refurb these things. You can do it. It'll be fun for you. This is your hobby. And then give it to a local school, but that's not enough. Walk it in to your local school. If you have a kid, go to the teacher, like to show up.
Such a cool project. Open days, bring it out, get them involved.
And so the real thing that they have to offer, and some of these makers, you know, they're a little bit scared of public speaking, or, you know, they don't feel like they're good teachers or something. But trust me, if the teachers teach, they'll have an environment that these kids can thrive in. But what they'll need is someone to have their back when the printer breaks.
Yeah. It's a clog or whatever.
You'll be the expert. You're the one that built it. So we got Philibot on board, and they donated tons of filament, and we're working. This is the next, I don't want to say phase because it's not formalized yet, but I'm dealing with a couple of guys that I got filament extruders to. I think the next phase will either be a straight-on pellet extruder that you can strap on to your printer bot or whatever you built. And it won't be the small little adopter bot because that thing's tiny. But I could see schools start to use pellet printers.
To save on cost,
To save cost and to start recycling, which is a beautiful thing.
Yeah.
So I'm hoping that we can get that going. I know that there's a University of Southern California I forget where they are. It's down in SoCal. They've got even a business that has grown out of first the art department, and then they've branched out into really building these huge art installations from all 3D printed parts.
Yeah, I like I'm an artist myself, so I really appreciate people being creative with 3D printer.
Simultaneously, they were like, "Oh my gosh, we have a lot of failed prints." I mean, their early efforts, there's a lot of failure.
But you want to recycle as an artist. You value your materials. It's like ink. You value your materials, and you know you have to try to recycle them. You want to recycle, but there's nothing there at the moment, really, to actually do it. And I've been so many places where people have put work together, and you want to recycle it, but it's really difficult to. I mean, what I do with some of my stuff is I remodel it into other things. And we try to work with it, and some of my I store because I'm hoping some point where I'll have a recycler where I can actually extrude my own filament with special compositions. But time it'll come.
Yeah, so you've seen over time these little Kickstarters or people that like just show up. Like Rich Rapp was one of them. He just built a filament or a pellet extruder and put it on. It was somewhat crude, but you could get off the shelf parts and do it. So there's some brilliance that have come along, little bright spots along the way, but there's no incentive for a 3D printer manufacturer to make a recycler work because it's a profit center, filament. But I think it's a crying shame, and I'm willing to do it. And I know Philibot, since they're focused on that sole thing to make pellet extruders, to extrude filament, but I'd like to skip the filament altogether and just go straight into pellets. Now, one of the things that simultaneously people wanted higher resolution prints, but they want a pellet printer. Those two don't really go together. You really need to be okay with a lower resolution, a higher layer height, or a bigger nozzle. Because when you recycle, one of the big problem is just the pollutants, the labels, the little pieces of paper in the plastic bottles or whatever it is. So if I want to start by building large printers with big nozzles that print lots of volume.
6 mil nozzle.
Yeah, and like 2, 3, 4, 5 millimeter tip, where it is no problem. Just let the trash come through with the plastic.
Not an issue.
Let's print some larger things, and that's one reason I think that manufacturing is getting excited about 3D printing right now. Is bigger printers have come out, and now there's all sorts of newer applications. But for just a school, a high school, a college, a large printer with a recycler, I think that's going to be a real thing this year.
A lot of sharks are coming out at the moment, as you say, but I think you're right. A lot of colleges, universities, art colleges actually moving to they're incorporating 3D printing into their courses, and they've accepted it as being another tool, basically, which it is another tool for them to be creative.
Absolutely.
One more thing I'd like to ask you. Final question. How do you see the future?
Well, I do see, the biggest hurt that 3D printing here in America, and maybe worldwide, has seen was this overhype of 3D printing. It's not the Jesus phone, It comes with some very real challenges, and like I did a video a couple years, 3 years back, that while Bree Pettis was saying, print anything that your imagination can think of. I love Bree. He's a great marketer, man, but that's not me. I wanted to say, I wouldn't want my customers to think that they could print anything. I'd rather them know 3D printing is hard. So I did a video and said 3D printing is hard. It's still hard. It's getting easier, and I think that machine I just showed you really takes a big leap forward. But that hype really led to disappointment among these, enthusiasts or early adopters, and it did a disservice. It also, a lot of stuff I'm not trying to pick on China. I'm just saying they have cheap printers, and there's a reason that they're cheap. They're made with sub-quality, sub-standards, often, not all, but often. They're kits that are poorly documented, language barriers, and like no support. And they're sold on Amazon or monoprice, and there's some standouts within a very narrow PLA plastic only, and going very slow at a very not any model, but like simple models. The monoprice Select can be a good first foray into 3D printing that won't break the bank. But the problem with China coming in with all these cheap printers is it forced innovators like myself, who I don't build the cheapest printer anymore. That's gone. China wins that race. They won the race to the bottom. But along with dragging everybody's barrier to entry down so that they could afford it and their pocketbook wouldn't be broken. It also drug down the user experience with 3D printers, and that spreads
and expectations. Yeah,
that spreads very fast. So now we've got all these people saying 3D printers suck, and that's kind of over now. But it's improving now. So now people realize that it's just like when cell phones started. The internet cell phones came out.
Oh yeah,
I remember going across the street with my neighbor, and I had the brand new iPhone, and he had the BlackBerry.
Yeah.
And he was like, "No, this is great. This
BlackBerry was it, wasn't it?"
And I was like, "Yeah, but that's not really a browser. It's like being filtered and like squashed out. It's not really a computer. It's like a phone that also does texting." Anyway, the point is, now people see what a 3D printer. Are you doing? Sorry. Now I think people see that quality matters, that user experience matters, that the Chinese printers aren't going to rapidly bring 3D printers to the masses. They're actually a bump in the road that we need to get past. Some of them will go back, the Chinese makers, some of them will go back and make a solid, quality, easy to use machine.
Yeah.
And the opportunists will go away. And companies like myself will decide, I'm going to invest in and that means real money. I mean, it's very expensive to do software. You're developing firmware, software, electronics, hardware, materials, all at the same time. And that user experience is all bound up in all of those things.
Yeah.
So some companies are going to emerge strong and with great user experience. And we can only begin to get these printers into every home.
Yeah.
But that problem remains. What are you going to print? And that's going to be a longer term problem that we have to solve. So education doesn't have to solve it because we know what education will print.
Yeah.
Lots of beautiful little things, some of them insignificant, some of them significant, to teach about our world around us. But, a guy or mom at home.
What are we going to print? I mean, I've got laser print book. I've got laser printer here. I haven't used it for 9 months.
Yeah, exactly.
And it's a terrible waste of technology.
Yeah, I'm not mailing newsletters anymore. And so,
no, those days are over. DTP killed the printing market,
So I do think that this year we will see some, like you said, you were excited about manufacturing and new ways to manufacture, but I think we're on this 20-mile march. It's just little, if you know the story about the guy the race to the South Pole, there's one company that came in with all this technology, diesel tractors and tanks, and they're going to race to the South Pole. And then there's this other team that brought like sled dogs, and they said, we're going to go 20 miles a day. And this 20-mile march, as soon as they landed with the one team with their tanks, when they landed, they immediately froze. And they started to try to walk to the South Pole. That didn't work out. They all died. The 20-mile march, in good weather, they would stop at 20 miles. In bad weather, they'd push through 20 miles. So it's the companies that are willing to do this 20-mile march every day, make a little improvement. There will be an inflection point, a watershed moment, where, the killer app is here, and these printers that are easy to use and affordable are here, and the materials are here, and it's going to really take off into homes like, the color TV, the VCR, the microwave oven, the computer, the laser printer. So, but we just aren't there yet. I personally am drawn to printing more complicated things that as a search for the killer app, that you have to actually also solder and also, maybe CNC something or buy a part or, it's a tool really. The 3D printer is just a tool. And I think the killer app will probably not be a piece of plastic or, some fancy metal electronics 3D printer and you're going to print cell phones. I don't think that's going to happen anytime soon. I think it's going to be something that does real work, that has real value, that you would have to go to the store and spend a lot of money on. It could be a wind generator. It could be an electric motor. It could be, who knows. But that isn't going to happen in 2018. But I think we'll see some very bright spots in niche areas where they're using 3D printers, like Reebok is one. They are seriously going to use 3D printers, the carbon SLS printers, to make the shoes that you will buy and wear. I mean, that's going to happen.
Yeah.
So it's things like that that will be bright spots in niches. Maybe we'll see real 3D printed homes, but again, it's a niche. So I think 2018 will be more of this exciting development of 20 Mile March, incremental improvements that really start to have products appear that are a pleasure to use, easy to use, and do things that, you know, just blow your mind and have great usefulness in small niche areas, but still leave the general public wondering, is a Yoda head really all that we can do with these things?
Yeah. Brook, thank you so much for chatting with me, Afro 3D Printer, and giving us your thoughts for 2017 to 2018.
Yeah.
Happy New Year to you and your family and your company, your brilliant company there. Thanks so much for sharing your time with me. Much appreciated. And we look forward to a more prosperous 2018 for everyone, I think.
Thanks so much, Afro. You take care. Thanks. And keep printing, man. Happy printing. Nice Happy New Year.